depend on the agriculture. Then we from the farm move to the city. I will introduce the urban land surface environment monitoring with remote sensing. It will make the city life more beautiful. I'm Meng Qingyan from the Aerospace Information Research Institute, CAS. Perhaps you know China is promoting to construct the beautiful China and eco-civilization to improve people's livelihood environment. And the urban eco-environment affects the comfortness and the perception of residents. Studies the urban land surface environment, which has great effect on the urban environment and its livability, closely related to people's daily life. And it's the internal mechanism, very complex and has become a very important research hotspot. Then we focused on the urban green, urban heat, and the urban water, urban humidity, which belong to the natural elements of the city. Also, we studied the urban green, it including the impervious surface, the urban streets, urban buildings, and so on. Also, we can use the urban brightness. Then we decide the city's livability. So I will introduce from these 6 parts, which is urban green, urban heat, the urban green, urban humidity, urban brightness, at last, the urban livability. The first, I will introduce the first part, the urban green space remote sensing. We call it perceiving the urban vegetation from the multi-dimensional and the perspectively. Okay. You know, the urban vegetation play very important role in the city. It has many benefits, such as the cooling, the increasing humidity, purifying the air, and so on. But there existed the unbalanced distribution of the urban green per capita. You see, in Cairo, in London, in Thailand, in New York, in Beijing, it's the different way. Even in the same city, in the different part of the city, in the first ring, the second ring, or the 6th or 4th ring, there exists the unbalanced the distribution of the urban green per capita. So facing a lot of the urban environment problems, and we put forward how to estimate the urban green distribution, how to estimate the probability of the resident contacting the green and the level of the enjoying the green. What can the remote sensing do? So we focused on the urban green space. It refers to the vegetation cover in the city, including the urban forest, the grass, the avenue trees, the park, and white land. It has a certain eco benefits, positive influence on our environment, and of convenient accessibility. The UGS, the urban green space, emphasizes the 3-dimensional characteristics of the urban vegetation. So we study on the urban green space remote sensing, which is measures the quality, the quantity, and the human perception of the urban green space quantitatively from the multi-dimension, multi-angle, multi-scale, based on the multi-source remote sensing data and combined with the GIS technique. aiming at realizing the comprehensive evaluation of urban green space structure,
https://data.fao.org/
from the three
At Dr. Jaweria Shamshad, there's another initiative on rural energy
to study the highlight the spatial distribution of the urban vegetation from both the vertical and the horizontal dimensions. Okay, so which is the three-dimension analysis of the urban green space. So we put forward the urban green space index. It's a new index which aiming at estimate the urban green from the spatial perspective based on the high-resolution remote sensing image and consider the green type, the building distribution, and so on. So we can see it. Then first we have the classification of the urban green space. We can from the two dimension. Also we can from the three dimension. I will introduce it. It's the retrieval of the vegetation and the buildings. We use the NDVI and the other method, many methods to classify, to recognize the vegetation and the urban buildings, such as we use high resolution satellite data, we use the LiDAR and so on. So we use OTSU method, OTU, which can be used to screen the threshold automatically. Then the vegetation can be retrieved without the subjective factors effect. Okay, then we get the vegetation retrievals. We can get the four color images and the vegetation retrieving result and so on. So then we can monitoring the vegetation change in a CEP at the different temporal scales. Also, we can use LiDAR and the other data. So we can retrieve some buildings parameters, such as the building's height, the area, and the volume. Also, then we get the buildings retrieving result of the whole research area. Then we use some high-resolution satellite data, such as the GF number 7, also the ZY3. We can retrieve some height of the buildings. Also, we can use the LiDAR and some other data to retrieve. Then we can also retrieve the three-dimension canopy parameters of the urban vegetation. So we can retrieve the tree top detection, and we can get the tree crown, and then we can calculate the canopy crown volume. We can see from the front view of the urban trees, and we can get the top view. Then we can also get the tree tops with the LiDAR, and we can also calculate the crown height, and we can get the radius of the crown, and then we can calculate the crown volume just like it. Only the tree crown with ellipsoid shape will be considered. Then we can study it. This is the map, including the height and the geographical position information of each tree top. Then we use some method to get the tree top detection. Use the head crown diameter hypothesis, and we search it, and also we can construct some models. Then we get the tree crown delineation. Also, we can calculate the. It's just like a embrace of the umbrella. So we call it the umbrella embrace shape tree crown delineation technique. So we get use search get the boundary of the trees, and then we get it. Also, we can calculate the volume of the canopy. Then we get the 2-dimension and 3-dimension of the urban green, some parameters. We can keep on study it, the multi-perspective urban green perceivings. We can study it from the 2-dimension. We can also from the 3-dimension, the building scale, the floor scale, the street scale, and so on. So this is the building's accessibility to the green space. You see, this is the building, this is the vegetation. Then we can calculate to study the 2-dimension configuration. Okay, we can use the 2-dimension way. We can based on the building accessibility to the green index. It including part 2. But is we can use the length, okay, the building's length to by the adjacent building. Okay, we can also use it with the area index, just like the building area, to calculate the area BAGI parameter indicators, just like it. Then through analyze of the BNGI distribution, the probability distribution, and its difference of the citizens contacting the urban green space in the different area can be proven. And this method based on the area doesn't take into account the different urban vegetation types. It didn't consider it's the grass, the bush, and all the trees. So it has some limitation. So then we can study the 3-dimension. Okay, first we can see the building-oriented the urban green perceivings. You see, we are living or studying or working in the buildings. So using the buildings, we can study the spatial configuration of the buildings and the urban vegetation. Then we can have the trees, we can have the bush, we can have the grass, we have the space distance and the height distance. So use it geometric some knowledge or technique. We can construct some models. We can assume the grass height is 0. Then we can calculate the tree's height, and we can transform it into the model. We can study it to analyze the building's accessibility to the urban green space index. Also, we can consider the amount of the green, such as also we include the amount of the urban vegetation. Also, we consider the proximity to the urban green. Also, we consider the height and the density of the buildings. And then we use 4 parameters to construct the building neighboring green index. This is the simple index, the green index. This is only the vegetation and the buildings. This is the green index, and this is the building density. Also, we can also retrieve the leaf area index of the urban green. So we can combine these parameters, 4 factors: the green index, the proximity to green, the building density, the high building density, into the same indicator, the BNGI, just the building neighboring the green index, and to calculate it. Then we can analyze the different kind of the positions, place, such as the high building and high density area. This is the test 1, and we can study the low building and low density area. This is the test 2. The high building, the low density area, the test 3, we can study it. You see, this is the BNGI index. This is the green index. You see, in the high building and high density, which is the test one, the mean value, okay, and the median value were the lowest, lowest, and the standard deviation of the BNGI was the highest, okay, the highest. And it shows that the residents in such area enjoy least green space. In the three different area of the city, you see the GI is the same, but the BNGI is the different. It shows that the BNGI is more practical. It has more meanings and can take more factors into account, including the green distribution and the buildings distribution and so on. So it can tell us more information. So we can also study it. It's found that the BNGI was more practical and reliable, and like the distribution of the green index in the high building and the low density and the low building high density area. The gap of the proportion between the BNGI and the GI decreased always. So we can draw the conclusion that the BNGI consider more factors into it and was more practical. So it tells us that the urban green space distribution map combined the structure, the vegetation structure, the building structure, and the function of the vegetation, such as the leaf area index, by considering the eco-benefit releaser and the green space radiation together. So we can not only describe the configuration character of the urban green space accurately, but also quantify the difference in enjoying the green space service of human settlements. Okay, so we can see from the floor-oriented urban green space perceiving as the three-dimension perspective. So we can choose the different floor, the first floor, the third floor, the fifth floor, the seventh, the 10th floor, and to discover the horizontal distribution characteristics of the urban green space. So we see the first floor, which is the sixth, about 60, and the third floor, about 400. Also the fifth floor, 100, and the seventh floor, 34, and whereas at the 10th floor, it decreased about the 10. So we can see the green space radiation computation of the different height of the layer provide a quantitative method to describe the urban green space layout and the potential eco space. The height dimension expands the concept of the urban green and also review the blind spot of the urban planning effectively due to the lack of the knowledge. Okay. Also, we shouldn't always stay inside the buildings. We would like to walk outside. Then, how to exploring the street level greenery in terms of the visual perception. Okay, let's see. We study the street trees, the benefit of street trees, the sidewalking greening, and you see which street is more walkable. Okay, this is good. This is very poor. So a more visible street greenery to people can generate stronger, enjoyable feeling than a less visible street greenery. So we can how visible is the street greenery to the workers of the city. So we use the index, the green view index, which measures the amount of greenery that people can see on the street at the different location in a city. So we use a road map and randomly generate rated some sampling points. We use some study experiment area which is located in Hungary. So we get the sampled points. Then we walked along the street. Then we pursue the urban street trees. So we use also some geometric models. We can use the height and the distance and so on. So we can calculate the green view index. Which is the perceived the street level greenery is defined as the total area of the middle cross section of the canopy within the view distance to sample site. Then we transform from the ellipsoidal canopy to a elliptical visual scene. Then we use it. We propose the following equation using some geometric models to develop such models. Then we use the models. We can see this picture can show the calculation result of the 360 sampling site in the study area. And we can show the different dot sets denote refer to the magnitude of the GVI value with the tree height map rendering behind. You can conduct the Google Earth Google Map. In China, we can use the Baidu map and so on. Then we can use such a GVI index to calculate how can we pursue the urban street trees. So by selecting the green view index value greater than 100, we can easily identify the location that may look more greener in the eye of our citizens. So just like it, this is the green view index. The greener or greener, okay, just like it. So conclusion, the walkers can more likely to enjoy a greener walking experience in residential area than in the commercial area in our study area, just like it you see from the result. And we also put forward a three-dimension configuration curve of the green space. We want to provide the support and the reference for the urban green planning, which is our objective description of the vertical distribution of the urban green space. You see from the three-dimension configuration, we can see where it can reach the green radiation peak. Where is the height of the green radiation peak? And how long and the green radiation range, just like this. And here is a green space surface in force. Okay, we can calculate and compare the different areas, such as the residential area, also the commercial area, the teaching area, and the industrial area, and so on. And based on the three-dimension green space curve, we can assess the statistical parameters. And you see, and where we know where is the deficient green radiant space. Okay, where is the saturated the green radiant space. Okay, just like it, the different way, the different area. Okay, and where is reach the balance of the green point, just like the yellow point. Okay, And then we can compare it, the residential area and the commercial area and so on, which below the height of the green radiation peak are named as the green balance point and so on. So we can see the green space radiation computation of the different height of the layer provide a quantitative method to describe the urban green space layout and the potential ecological space, and just like it. Then we can summarize the first part. We retrieve the vegetation parameters, we measure it, and we develop some method to pursue the urban green. And we can also evaluate the urban green space. At last, we can provide the urban green space the planning for the end user, which just the interdiscipline of the urban green space remote sensing and the horticulture planning and the urban planning, just like it. As the second part will let us see the urban heat, monitoring. You see first the spatial and temporal analysis of the urban heat island. You know the urban heat island is a very, very fierce phenomenon that the temperature of the urban area is higher than the suburb way, and mainly due to the increasing the urbanization process. As a result, the natural surface and the trees are replaced with the tall buildings, the streets, which is the impervious surface and so on. So the urban heat island happened. So when how to extract the main urban construction area scientifically, how to combine the temporal and spatial organically to discover the spatial and the temporal evolution of the urban heat island, and how to analyze it. Okay, so the urban heat island is the most serious urban disease in the world. This side, the earth is ferocious. Okay, also just like it. Just the city has is also alive, just like a baby. When it's the baby is feverish, we will test the temperature. Then how to test the temperature of the city? So we should put forward some to classify the urban main build-up area. So we put forward a distance, weight, impervious surface, cohesion density. Okay, just like to based on the distance, weight algorithm to calculate the density of the impervious surface, we use some method, the pixels center, and use the different radius to calculate the impervious surface density, cohesion density. Then we can retrieve the city's area and the center ring and the outer ring and the inner ring and so on. So we can illustrate the city's main urban construction area based on the city cluster algorithm. If you are interested in it, I think later on I can send you some material. Because of the time limitation, I can't explain very detailedly. So we can retrieve the Beijing's main construction area boundary, and we can compare with others center urban area distribution of Beijing. They are similar. So we can study the urban heat island. You see, in Beijing, there are no variety. They have when it will decrease, when it increase, when it reaches the daily summit, the high point, when it's lowest point, it has some law. Yeah, very interesting. And from the different 12 months, you see the daytime, just like during the daytime, it show entity clockwise arrangement from the January to the December. Where is the clockwise pattern at night? It's very interesting. During the day, the month's urban heat and the intensity fluctuate always between the 0.5 K to 3.83 K and so on. And you see the different season. During the daytime, the Beijing urban heat island intensity is characterized with the apparent seasonal variation. Being the great in the summer, this is the summer. Secondly, in the spring, then the autumn, and the least in the winter. Where is at night the seasonal variation? Seasonal variation of the urban heat island intensity, you see, very close and relatively stable, and the base value of the 1 to 2K during the 12 years. It's 12 months. It's very interesting. I think you can also study your country's cities. You can find some interesting law, and you can treat the urban heat disease like it. Then we divide the urban heat island into the 5 level, and we study the 5 levels characteristics. You see, and it shows that the 5 level and the 4 seasons, it shows that during the daytime, the spatial distribution of the urban heat island appear to be on level 2 and level 3. And you see it just like the Beijing's different rain. It has a rain like a circle. You see, like a circle. It's very interesting. So many things, many laws we can find from it. Then we can see another technique, the thermal infrared remote sensing, monitoring the industry capacity. You see, based on the thermal infrared and the high resolution satellite, we can extract the temperature before and after the cutting excessive the industrial capacity. Then you see, from the satellite, we can retrieve the industrial area, such as the color studio room factors. Yeah, in the picture, the blue color studio factors can be extracted, and we can retrieve also the red color studio factors. Also, we can also retrieve some green color steel rooms classification, just like it. And we use a high resolution thermal infrared data. At night, we can know the temperature difference between the steel plant and the outer side. You see the right, the heat pollution, and you see the different phases of the Tianjin iron and steel factories. You see the different years, different months, infrared pictures, just like it. You see, here is very interesting. It's very hot, but here it's not hot. Why? Yeah, just like it. You see, why the temperature of the water here, yeah, is more higher than the temperature of the surrounding river. We check from the internet because it's the inception and has always attached the great importance to the environment protection and the energy conservation and the emission reduction. So, and some production facilities all support the environment protection. So it built the discharging the sewage, the treating plant, just like it. Yeah, this is from the infrared remote sensing. You can see it. and we can see the different months, the different temperatures difference, and also we can see when the factory is moved out, what happened, which is the mitigation effect of the industrial relocation of the urban heat island. We use some of the thermal pollution. Yeah, we use the Shogun group. Shogun means the capital China. Okay, it's a steel group, and sometimes it has steel making, the steel rolling, the industrial processing, and the coating, the sintering, and the iron making, and so on, which produced a lot of the waste heat, caused the loss of the usable energy and the environment pollution. So the state council approved that the Shogun group should be relocated from the Beijing building in 2005, and little by little, year by year, it be stopped production, and at last, it ending the production in the 2010, and which is moved out. Then you see from the different year, and little by little, and something like it. Yeah, some things like it. Yeah, in the May 2010, there was still some steel production. Yeah, just like this picture, and also appears some area it has stopped. The color is changed. In the 2016, after the relocation, you see the temperature of the level fell, disappeared. Okay, and the urban urban heat rate index decreased also. Also, you see from the dynamic of the urban heat island after the relocation of the restructuring, you see after 11 years, a general decrease of the urban heat island can be found, as the green patches representing the decreasing of the temperature area are larger than the red patches. Okay, just like it. So it has very good effect on the boundary river, the Yongding River. You can see the Yongding River increasing. Okay. The green patch increased after the relocation. Yeah. Also, we can see the urban green, which is the urban impervious surface retrieving. Okay, and we can also see the using application 8. The urban impervious surface, we call it the urban green, refer to the cover type, which prevent the surface water from direction seeping into the underground soil. So, such as the roof of the buildings, the cement, the road, the asphalt covered road, and the other infrastructure. You see, this is the various type of the impervious surface, and then there happens the urban waterlogging, which is the urban disease. Okay, urban disease also. This is the Beijing 2012 suffered a very, very heavy rain that caused serious the urban water lodging, and someone passed away during the urban lodging. This is the Wuhan in the flood season in 2016, and the 24 hours rainfall. Okay, this is also the water logging of the Beijing, and this is the Wuhan University. Some expert side, the spin to the Wuhan University to see the cherry blossom. Yeah, this is. And the summer to Wuhan University to see the sea. Okay, it's very interesting. And why? It's because of the the city's impervious surface accounting over 70%, and the 50% of the perception needed to be discharged by the surface runoff. So this is the impervious surface. So we can study it as a period river data. We can see the different way we can study the percentage of the impervious surface impression and the expansion rate. We can see it. The impression of the impervious surface is generally slowed down, and the annual growth rate was highest from the 1990 to 2000, and then gradually slowed down. Okay, the Guangdong, Dongguan, Shenzhen, and Foshan, Zhuhai achieved the rapid growth during this period. Since the 2000, the impervious impression explore of the city slowed down. Okay, we can also study the impervious surface has a very positive correlation with the GDP, the regional permanent population, and the per capita GDP also. It's very intuitive. You can study your country's way. Okay, and we can study also the distribution. Okay, we can the east way and the east-west direction we can study. Yeah, the axis is a purposely normally distributed center around the Guangzhou city, and the proportion of the impervious surface in Foshan, Guangzhou, and Dongguan is very high, just like it. Okay, and also we can use the landscape index to study it, such as the plan, the NP, the patch density, and so on. And we study it, the plan, the NP, the PD, and we can study it. And we can see, and after more than 20 years development, the area of the high value of the assemble index has increased, and mainly in the center and the south region of the area, representing by Guangzhou, Foshan, and so on. And we can analyze which way it expand and so on. So we can use it another way. We can use it in the surface runoff. We use a model, American model, which is the CN value. And use the value, we can study another city, the Hangzhou city. You can see that the city's CN value of more than 90 in the study area is mainly concentrated in the this district, the Shamshad district and the Xiacheng district, the upper downtown and the lower downtown. The two areas has very high impervious surface density, just like it, and smaller vegetation and soil moisture, and the less than 90 cn in the study area is mainly distributed in the West Lake area and the nearby area, just like it. It can be seen also from the rainfall increasing of the 250 method. Okay, the study area produce 220 to 240 millimeter runoff continuous, and you see it spread. The purple and the dark purple in the figure is increasing, indicating that the runoff in the study area has been increased and spread. Okay, and we can use the urban humidity. We can retrieve the urban waters, use some method, decoupling the water and the atmosphere interception procession, and we can decrease the neighboring pixel and so on. We can retrieve the water water body, urban water body automatically. Then we use our method such as the BRAT. This is the coupling method to compare the NDWI and the visual retrieving, and we retrieve a very satisfactory result. Okay, this is we use some way to decrease to difference the water and some shadow and the liquid. And we can retrieve the Beijing's water body and so on, use the GF number 1. We can also, we study the Sydney, the Melbourne, and so on. We can also retrieve the building shadow, the water and the mountain shadow, the water and the different water quality, water, so on. We can also study the black and other water in China also. We use the monitoring of the water transparency, okay, and dissolved oxygen, the saturation, and so on. We use the different kind of the water type and the black other water body and so on, the common water. Okay, we can use the Jinan, Taiyuan, and also we can use the black border. Okay, then we see the urban brightness. We can monitor the house vacancy and use the nightlight data. Okay, the house vacancy problem cause the waste of the social resources and so on. We put forward indicator. We call it the house vacancy descent. HVI. We use impervious surface and combine with the nightlight parameters together. We develop the HVI. We can study some channel. You see, for the large developed city, the vacant house exhibit a radical distribution pattern, and various the less developed cities, it has no obvious pattern. And we can study the different way from the 2000 to 2050. The house vacancy in China was gradually weakening, but some HVI in some less developed cities increased. We can also study the ghost city. In China, we have some phenomenon, the ghost city. Okay, we put forward the ghost city index, the ZCI, and we study the China. And it mainly located here, the North China and so on. But in some developed area, the low and western area, China is separately, spatially populated, also low. And we can study the top 50 cities of the ghost city in China, and we compare it, and it show compared with some U.S. area, and we see the among the 50 ghost city, about the 21 ghost city appeared in the other reported rankings. It's very interesting. We can study also the poverty monitoring, use the nightlight. We use the total nightlight light index, average nightlight average. We study it, and we study it. You see, this is the Hebei some counties and some result. And you see, it has in Xinjiang and Gansu and in the Mongolia also backward, which are not included in the key spot object. This is some pattern located distribution. This is the located CPI index in Xinjiang and some cities in Sichuan and so on. Also the Moran index studies, and it has some obvious aggregation phenomenon. We can study it and compare it. You see, and we can use it in many areas. Use it as poverty monitoring and so on. At last, we see the levelability. of the city monitoring. We use all the urban green heat, the urban green, urban humidity into together, and we study it as urban livability. And we can see from it that the Beijing, the level 2 a suitable area, and the totally and is about the suitable area for the high quality living area in Beijing, about 80%. Also, the LISA cluster mapping of the Beijing, we can see from the 2008-2013, the livability of human living environment has changed steadily. And from this period, and the Beijing's livability has improved. Okay, we compared with the livability of Beijing and with the income of Beijing, and found it very correlated, and it's very interesting. It can test each other. So we can combine the urban green space and the urban heat, the urban green, and the urban water humidity, and the urban soil, we call it urban darkness, and the urban brightness. We can conduct the dynamic remote sensing monitoring of the urban environment quality and the livability, and we can output some monitoring report and the urban environment monitoring green paper to provide the decision support for the urban government eco-environment protection. Okay, we say that the city is a highly concentrated embodiment of the human civilization, and spatial information technique can make the city smarter and make our urban life better. Okay, that's all. Thank you. Okay.
Thank you, Professor Men. I have to see the presentation is very informative and a lot of detail from the research outcome.